In this lesson, we will discuss how to name molecules containing three more functional groups: ethers, carboxylic acids, and esters. We're going to look at somewhat simpler examples than we looked at in the case of alkanes, because I just want you to get a sense of how you handle these functional groups, kind of the big picture of how to name them. So we will start with ethers, and for ethers, common names are almost universal. And the way you construct a common name for an ether is you list the substituent on each side of the oxygen, followed by the word ether. So a couple of examples will make this clear. Left-hand example is an oxygen with an ethyl group on each side. So the way we name this is we call it diethyl ether. If you haven't yet met this molecule in the lab, you will fairly soon, because this is a common solvent that's used for a lot of experiments in the organic lab. The molecule on the right has a methyl group on one side and a tert-butyl group on the other side. Tert-butyl groups are sometimes abbreviated T-butyl groups because that's just a little bit shorter to say. So this molecule is simply going to be called methyl T-butyl ether. This is another common molecule. It's known as Mtbe, and Mtbe is sometimes added to gasoline in the summertime to oxygenate the gasoline and make it burn cleaner. It's an alternative to adding ethanol. It's okay to name this methyl first and butyl second, even though B becomes before M alphabetically, because this is a common name and rules about alphabetization get thrown out the window when we're using a common name. Should you want to name an ether systematically, it is possible to do so. And in some cases, if the ether is fairly complex in structure, you're actually going to want to name it systematically. And the way you handle that is you treat the substituent as an alkoxy substituent on an alkane. Okay, so let's look at an example of one that we could name systematically. When you're doing systematic names, you have to identify the longest carbon chain. So in this molecule, the longest carbon chain is a 3-carbon chain going from left to right on the top of the structure. Oxygens are not included in the longest carbon chain. So you have to remember that even though there is a continuous chain of 5 atoms that has the oxygen in the middle, the longest carbon chain is a 3-carbon chain. Therefore, it is going to be a propane derivative. Then the substituent is coming off of carbon 2 of the propane, the central carbon, and it is an ethoxy group. Okay, Eth for the 2 carbons, oxy for the oxygen. So this molecule would be called 2-ethoxy propane. Moving on to carboxylic acids. Carboxylic acids are actually a very frequently occurring functional group. We will start by talking about how to name them systematically. Then I'm going to tell you people don't use the systematic names that much. The way you would name it systematically is that you drop the final E from the parent stem, just like we did for alcohols, but then instead of adding an OL ending, we add an oic acid ending. Okay, so let's look at an example of a 2-carbon carboxylic acid. Organic chemistry E's for 2 carbons is eth. So instead of it being ethane, we're going to drop the final E, and it's going to be ethanoic acid. Okay, 2 words. Ethanoic space acid. We can do more complicated molecules this way. This is a longer chain. Instead of being just 2 carbons, it is 5 carbons, so it's going to be a pentanoic acid. But coming off of carbon 3, there is a methyl group, so it's actually going to be a 3-methyl pentanoic acid. How did I know that that was coming off of carbon 3? Well, when we're numbering the chain, the carbonyl carbon for the carboxylic acid has to get carbon 1. That basically tells me if the COOH is on the right side of the molecule, I started carbon 1 and I'm numbering up to the left. So the methyl group comes up at carbon 3 to give the name that I've already given to you. Common names are very widely used for carboxylic acids. Many of them are historic. Okay, so for example, ethanoic acid is also known as acetic acid, the active ingredient in vinegar. And once again, if you called a chemical company and wanted some ethanoic acid, they probably wouldn't know what you were talking about until you told them what you really wanted was acetic acid. That's how common that common name is, and that's one that I also would recommend that you memorize. Your textbook, I'm sure, has more examples of common names for carboxylic acids. Some of them are rather funny. So the 6-carbon carboxylic acid is called caproic acid because it was actually first isolated from goat sweat. Okay, a lot of carboxylic acids are really stinky, and they've been isolated from places in nature where you don't want to spend a whole lot of time smelling. But, you know, a long time ago, that's where natural products were isolated from. So since caproic acid comes from goats, and you may remember that that same root comes from Capricorn, the goat, the constellation in the sky, it's called caproic acid. The 1-carbon carboxylic acid is called formic acid because it was originally isolated from distilling ants. And the root for ants is formic. There are other ones. The 4-carbon carboxylic acid is called butyric acid because it smells like rancid butter. Okay, again, not stuff that you would necessarily want to be smelling. But there's a solution to the bad smells of carboxylic acids, and that's to convert them into esters. Carboxylic acids have bad smells. Esters have really nice smells, and they're very fruity smelling. They're derivatives of carboxylic acids. They're alkyl derivatives of carboxylic acids instead of just having the OH. So when we construct the name of an ester, we need to indicate both the alkyl fragment and the carboxylic acid fragment. Therefore, our name is going to have 2 words. Okay, so the first example I'm going to give you of an ester is ethyl butanoate. Okay, how did I get this name? Well, my recommendation for naming an ester is always to orient the molecule such that the oxygen in the chain is to the right of the carbonyl group. Then word number 1 is simply the group to the right of the oxygen. In this molecule, it's a 2-carbon group, so therefore it is an ethyl group. Word number 2 is the carboxylic acid fragment. So that it is a 4-carbon carboxylic acid counting the carbonyl carbon. You can't neglect that carbonyl carbon. And then you get the ending oate instead of oic acid. Okay, so ethyl butanoate. Okay, let's look at another example. So this molecule, we have a branch on the right-hand chain, if the molecule is drawn as I've indicated that you draw it, and we have to have 2 separate numbering schemes. We need to have a numbering scheme for the alkyl fragment and then a separate numbering scheme for the carboxylic acid fragment. For the alkyl fragment, we've got a methyl group on carbon 3, and it is a 4-carbon fragment. The carboxylic acid fragment is a 3-carbon fragment. Therefore, this molecule is going to be named 3-methylbutyl for the group on the right, propanoate for the group on the left. Now, always remember, when you're using rights or lefts the way I'm suggesting in this lesson, you want to have the molecule oriented so that the oxygen in the chain is to the right of the carbonyl group. I said that already, but it's worth saying again. And then finally, for esters, common names are also frequently used. Example 3 is another molecule that is commonly used as a solvent in the lab. It has got an ethyl group on the right-hand side of the oxygen, so its first word's going to be an ethyl. If you were to name this systematically, you would probably now tell me that its name is ethyl ethanoate. But if you recall on the last slide, I told you that ethanoic acid is actually called acetic acid. Therefore, ethyl ethanoate is commonly known of as ethyl acetate.